So in today's lesson, we're going to be talking about sequences and series. Now, most of the time, sequences and series are a Algebra 2 topic, but they are towards the end of the year. And so this was one of the things that we didn't quite get to last year since we were out of school. So we're going to go over it this week. Now, there are some different types of sequences and series. There are two main types. They are the arithmetic, which we're going to be going over today, and then the geometric, which we're going to be going over tomorrow. So first, let's kind of define what is a sequence and look at specifically what it means to have an arithmetic sequence. So a sequence is going to be a set of numbers in a particular order. A term is going to be each number in a sequence. So basically, a sequence is just going to be a list of numbers. And it matters what order they're in. So they do have to be in a particular order. And we call each of those numbers a term. Now, there can be all different types of sequences, but if we specifically wanted to have an arithmetic sequence, the way we get those is by having each term in a sequence is determined by adding a specific constant to the previous term. So notice an example of this could be, say, our even numbers. So 2, 4, 6, 8, and so forth. So the ... just means that that pattern is going to continue. So notice that in between each of our terms, which is just the list of numbers that we have there, we are adding a constant of 2. So 2 would be that constant. Now, in general, if we want to find a specific number, like if you wanted to find the 12th term, or the 100th term, or the 80th term, we can use this formula that we have here. So it says the nth term, a sub n. So it is a subscript. So instead of a superscript, like our exponents, it's a subscript, which means slightly below, of an arithmetic sequence in which the first term, a sub 1, and the common difference, d, is given by the following formula, where n is any natural number. So a natural number is just going to be a counting number. So 1, 2, 3, 4, and 5. We can find it using the formula a sub n equals a sub 1 plus n minus 1 times d. So if I was wanting to find the 12th term, I would have a sub 12. If I was wanting to find the 15th term, I would have a sub 15 equals whatever your first term is plus n, which is whatever term you're trying to find, so 12, 15, whatever it is, times d. Now, your common difference is going to be that constant that we were talking about, which seems a little backwards because technically we're adding something to each term. But notice that if we wanted to figure out what that constant is, in order to be able to go backwards, we would have to we would have to subtract 2 of our terms, and that would be that common difference, or the common constant. So let's look at an example. It says, find the 12th term of the arithmetic sequence 9, 16, 23, 30. So first, let's just write out our formula. So a sub n equals a sub 1 plus n minus 1 times d. And we can go ahead and fill in a lot of this. So we know that we're looking for the 12th term, so that would be a sub 12. We know that our first term is 9, and again we have a 12 minus 1, but we don't know what our d is. So remember that d is going to be that common difference. So if we want to find that common difference, all we have to do is take 2 consecutive terms and subtract them. But do be careful because you do need to select the second term. So like if I wanted to use 23 and 30 instead, that's fine, but you would need to do 30 minus 23. So you always want to choose the second term to put down there first. So then we know that we're multiplying this by 7. So a sub 12 is going to equal 9 plus 11 times 7. So we get 9 plus 77, which is going to be 86. And so that would be our final answer. So we know that if we continue in that same pattern, that we would get 86 when we get to the 12th number. So it says write an equation for the nth term of each arithmetic sequence. So sometimes they don't want us to find a specific one. They want us to find just the general formula instead. So again, we're still using that a sub n equals a sub 1 plus n minus 1 times d. Now this time, instead of plugging in a number for n, I'm going to leave that as the variable. So my first term is 5. I'm going to leave the n as an n, but we do still need to find our d. So we have negative 13 minus 5. Because remember, we do have to choose that second one first. So negative 13 minus 5 gives us negative 18, which is okay for us to have a negative d value. Basically, each time that we're adding, we're actually subtracting a number. So we would want to then say that this is negative 18. So we would want to go ahead and distribute that negative 18 and then simplify. So we get negative 18n plus 23. So in order for me to find any term in that sequence, I could use that formula. So before, we're going to say we were looking at our even terms. we listed them out as just like 1, 2, 3, 4, 5. If we want to look at a series, this time instead of having commas, we're actually going to have plus signs. So it is the addition of a sequence. So like with our example with our even numbers, we had 2, 4, 6, 8. But this time instead of putting commas, we're going to put plus signs in between each of my terms. So for an arithmetic series, we have two different ways that we can find the sum. There's S sub n equals n times a sub 1 plus a sub n divided by 2. And we also have S sub n equals n divided by 2 times a sub 1 plus n minus 1 times d. It just depends on the information that they give us. So in the first one, that would be if they gave us a sub 1 and a sub n. And the second one is if they gave us a sub 1 and d instead. So let's look at an example. It says find the sum of 12 plus 19 plus 26 plus, and we're going to go all the way to 180. So first, let's just write out that sum formula. So I have S sub n equals n times a sub 1 plus a sub n divided by 2. Now, notice that I know that my first term is 12 and my last term is 180. But we don't know what number of term 180 is. We know that 12 is the first term, and we know that 180 is the last term, but we don't know how many terms are in between in that dot dot dot. And that's what's going to be our n value, is whatever number of term 180 is. So we need to find that first. So what we're going to do is use our a sub n formula to kind of work our way backwards. So notice that we know what a sub n is this time. We know it's 180. We know that our first term is 12, but we need to figure out what n is. Also, notice that if I were to subtract 19 minus 12, we get that our d is 7. So then we just need to solve. So I'm going to distribute that 7. We have 12 minus 7 gives us 5. We're going to subtract 5, divide by 7, and we get that n is 25. So we know that 180 is the 25th term, so we are wanting to add together the first 25 terms. So if I do 12 plus 180, we get 192 divided by 2, which is going to be 96. And then 25 times 96 is going to give us 2,400. So that would be our answer. So that means that if I took and I plugged it into our calculator and I did 12 plus 19 plus 26 plus, and I keep adding all the way until I get to 180, we would get 2,400. Well, this formula, even though it took us a little bit, is still a lot faster than trying to plug in all of those numbers into our calculator. So let's find the sum of this arithmetic series. So notice that these are even numbers. We've talked about them a couple of times now. Okay, so we have S sub n equals n times a sub 1 plus a sub n divided by 2. So we know that our a sub 1 is 2, our a sub n is 100, and hopefully we can recognize that because we're skipping every other number, that we would have half the amount of numbers. So 100 is going to be our 50th term. Now you could use the same process that we used before with the a sub n, plug in 100 and solve for n if you needed to, or we can kind of think through it logically since we know that we're skipping every other. So we get 102 divided by 2 is going to give us 51. So we know that the first 50 even numbers, if we were to add them all together, we get 2,550. Alright, so sometimes when we're looking at a series, it's going to give it to us in summation notation instead. So basically what this does is the number at the bottom is going to be the starting value. The number at the top is going to be the ending value. And whatever's to the right side is what we're going to plug into. So notice here they give us a formula. They tell us that we're going to be plugging in 4 first. So notice that if I plug in 4 first, I would have 6 times 4 minus 1. And then that is my first term in my series. And then we're going to add, and then we're going to plug in our next number. So 5. So 6 times 5 minus 1. And then we're going to add, and we're going to keep going until we get to plugging in 18. Okay, but notice that would be a really long process to try and do all of those. So we want to be able to use that formula instead. So notice that our first term, if we plug that in, we would get 6 times 4 gives us 24, minus 1 gives us 23. 6 times 5 gives us 30, minus 1 gives us 29, and so forth. So notice that if we wanted to use that formula again, we have S sub, well, we need to figure out how many terms that we are adding together. Okay, now notice that I know that I'm going to start at 4, I'm going to go all the way to 18. So if I wanted to know how many numbers are in between 18 and 4, I would do 18 minus 4. But be careful, because realize that if I just did 18 minus 4, I'm looking at how many numbers are in between 4 all the way till I get to 18. But because we had to plug in 4 first, we have to add in an extra number. So we get 15. So we know that we're looking at the sum of the first 15 terms of this series. We know that our first term is 23. Then notice that we also need our last term, so we would need to do 6 times 18, which is 108, minus 1, which is going to give us 107. So that's what we need to plug in for A7. And then we can simplify. So we would get 23 plus 107 is going to give us 130. Then we would divide by 2 and we get 65. And then 65 times 15 is going to give us 975. And that would be our final answer. And we would get the same thing if we just put it into our calculator. 6 times 4 minus 1, which is 23. And then we added 6 times 5 minus 1, which is 29. And then we added 6 times 6 minus 1, and so forth, all the way till we got to plugging in 18. We would get the same value by just doing this formula, which is a lot faster than trying to do that many.